Welcome to 9.2, where we're going to be dealing with naming and writing formulas for ionic compounds. Hey, in this podcast we're going to do exactly that. We're going to show you how to write formulas for the ionic compounds, and if at any point you start to feel that you have the pattern to these, go ahead and pause the podcast, try to work ahead, try to predict the formulas for these compounds, and then go ahead and play the podcast out to see if you get the correct answer. Okay. Now, I'm going to show you the basic theory behind why these compounds form in the ratios that they do, but then I'm also going to give you a shortcut method that will help quicken things up just a little bit. The whole idea behind these ionic compounds forming is that one is positively charged, the cation, and the other is negatively charged, the anion, and the charges are going to be balanced in the ionic compound. So in the case of sodium ion combining with a chloride ion, you have one positive, one negative, so one sodium ion will combine with one chloride ion, and you'll simply write NaCl as your compound, and that's it. Now, in other cases, scrolling down here, in other cases, you might have, say in calcium's case, you're going to have a +2 charge. The oxide ion is a -2. So the two positives will balance the two negatives, and once again you only need one calcium to balance the charge on one oxide ion, and the formula is going to be CaO. Scrolling down just a little bit more. With the aluminum, the +3 cation, and the nitride ion, a -3 anion, once again the three positives balance the three negatives, and so you only need one aluminum with one nitride, and the formula for aluminum nitride is Aln. Now, in many cases, the charge on the cation and the anion are not going to be the same, and so you're going to have to add more of one or the other to balance the charges. For example, up here, notice the potassium ion is a +1, the oxide ion is a 2-. So if you think about it in terms of charges, you have two negatives here, you only have one positive here, so these charges balance, but you have a negative charge here that is unbalanced. So you're going to have to bring in another potassium, which is going to bring that extra positive charge. So now you have two positives to balance the two negatives, and so it took two potassiums to balance one oxygen. And notice you put the subscript in there too, with the potassium to show that you have two of those to balance the one oxygen, or the oxide ion. Now in the next case here, you have magnesium 2+, so you have two positive charges, but the bromide ion only has one negative charge, so one positive is balanced, but you have another positive that's unbalanced, so you're going to need to bring in an extra bromide ion that's going to bring in an extra negative charge. Now it's balanced, and so one magnesium will combine with two bromide ions, so the formula will be MgBr2. Simple enough. Now in this last example here, at least of the first six, the aluminum ion has three positives. The oxide ion has two negatives. So two out of the three positives are in fact balanced, but it has an extra an extra positive charge, so that's going to require more oxygen. So when you bring in another oxide ion, you bring in two negative charges. It does balance that positive charge, but you still have a negative unbalanced, so you're going to have to bring in another aluminum. Now once again, we'll show you a shortcut method here, but this is just the basic idea behind why these form. So the extra aluminum brings in an extra three positive charges. That's going to balance that extra negative, but now you have unbalanced positives, so you'll once again bring in an oxide ion, which brings in the two extra negative charges, and now finally all the positives and negatives are balanced. You have a total of 6 positive charges with the aluminum, you have a total of 6 negative charges with the oxide ions, so it takes 2 aluminums to balance the charge of 3 oxide ions, and so the formula is going to be Al2O3. Now, the shortcut method. Alright, I will never write out those positives and negatives again. The shortcut method is simply this. You're going to take the numbers associated with the charges and you're going to crisscross them and reduce. So, going back to the very first example, the sodium has got a +1 charge. The one which is on there will go with the chloride ion. The one with the chloride ion goes with the sodium, so it's Na1Cl1, and of course we just write it as NaCl. In terms of the calcium and the oxide, the 2 from the calcium would go with the oxygen. The 2 with the oxygen would go down to the calcium, and so you might write this as Ca2O2. That's a 2 right there. But the 2 to 2 will reduce down. You can divide them both by 2, and you're back down to CaO. And once again, with the aluminum nitride, the 3 from the aluminum will go behind the nitrogen. The 3 from the nitrogen will go behind the aluminum. So you would be left with Al3N3, but because they're both divisible by 3, those reduce to a 1-to-1. So far so good. All of the formulas are as predicted. Going back up top here to the potassium and the oxygen, or potassium and the oxide ion, the 2 from the oxygen, the 2 minus, now again the charge, the actual positive or negative doesn't go with it, it's just the number. The 2 from the oxygen goes with the potassium. The 1 with the potassium goes with the oxygen, so you're going to get K2O, just as we predicted. With the magnesium and the bromide ion, the 2 from the magnesium will go behind the bromide, and it does. The 1 from the bromine, or the bromide, will go with the magnesium, and it does, so you get MgBr2. And the real time saver here, with the aluminum and the oxide ion, the 3 from the aluminum will go behind the oxygen. The 2 from the oxygen will go behind the aluminum. So once again, the 2 from the oxygen ends up with the aluminum. The 3 from the aluminum goes with the oxygen, and you're left with Al2O3. Let's go ahead and scroll down and try this. Try this out with a couple more compounds. In this compound here, you have copper, which is a +1, combining with oxide, which is a -2. So when you crisscross the numbers, the 2 will go with the copper, the 1 will go with the oxygen. So it's going to be Cu2O. In this next one, you have a +2 and a -2. Now you might recognize the 2 plus 2 minus, it's just a 1-to-1 ratio. Or if you crisscross and reduce, the 2's go with the opposite elements, so it's Cu2O2, but of course that reduces down to CuO. Sliding over here to the iron and the sulfide ion, and again you have iron 2 and sulfide 2 minus, the 2's crisscross, so you have Fe2S2, and that's going to reduce to FeS. And with the iron 3 plus, crisscrossing with the sulfur, which is a 2 minus, the 3 will go with the sulfur, the 2 will go with the iron, so it's Fe2S3. Okay, let's try a few more here. The lead 2 plus with the oxygen 2 minus, you crisscross it, it would be a 2 and a 2 there, but that will reduce down to PbO. In this case, down here, the 2 goes with the lead, the 4 goes with the oxygen, so it would be Pb2O4, but those are going to both be divided by 2 to form PbO2. And finally, at least for this page here, when you crisscross these numbers, the 4 will go behind the nitrogen, the 3 will go behind the tin, Sn, so you have Sn3N4. Alright? So, the basic idea behind predicting the formulas for these ionic compounds is you simply crisscross the charges and reduce to the lowest whole number ratio. In the next podcast, we're going to show you how to name these compounds.